right, guys, are there any questions on the homework assignments thus far? All right. What we're looking at today is the special properties of parallelograms. We're using special properties of parallelograms. We're going to deal more with kind of naming and identifying quadrilaterals more than anything else today. And then we'll delve more into the properties tomorrow and how we can use them and find different values associated with them. Now, the first core concept, which y'all have and it's pretty much blank on the first page, is pretty much telling us that a rhombus is a parallelogram with four congruent sides. A rectangle is a parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. I'd get a general definition of it. Because a rhombus, parallelogram with four congruent sides. Rectangle, parallelogram with four right angles. And a square is a parallelogram with four congruent sides and four right angles. So put it in a way that you best can understand. Any questions on this here? Has everybody got these copied down? Almost? Now, when we look at these definitions, you don't have to write this down, but I want to draw this out. Because the most general topic that we're going to talk about here is smaller. Is quadrilaterals. And what is, by definition, a quadrilateral? Four-sided figure. If it has four sides, we can classify it as quadrilateral, yes? Now, more specifically, inside quadrilaterals, as we've gone over, we also have parallelograms. Well, a parallelogram is a what? A quadrilateral with two sets of parallel lines, yes? So if we have a four-sided figure with two sets of parallel lines, it is a quadrilateral, yes? Because it has four sides by definition. But when we're talking about them and categorizing them, we're going to call it a parallelogram because that is the most specific definition for that figure. It does have four sides, but because we know that it has two sets of parallel lines, or we can actually prove from what we did last week that it is a parallelogram, we're going to call it that. Now, as we just said, squares, rhombuses, and rectangles are also quadrilaterals and parallelograms, yes? So we can say inside parallelograms that we do have kind of the category of A rhombus, because a rhombus is a parallelogram with 4 congruent sides. Now we also have rectangles. And what are rectangles? 4 right angles. Does it say anything about the sides? No, it's just a quadrilateral that is a parallelogram and has 4 right angles. And what's the last one? Square. Now, square is special because what is a square? So 4 congruent sides and 4 right angles. So can a square be a rhombus? Because what is a rhombus? 4 congruent sides. Well, what does a square have? 4 congruent sides. So can a square be a rhombus? Yes. Can a rhombus be a square? Because what's the other half? 4 right angles. So a rhombus only has half the definition of a square. But a square can be a rhombus, but a rhombus can't be a square. Now, can a square be a rectangle? Because it does have definition of rectangle. Can a rectangle be a square? No, because it doesn't necessarily have 4 congruent sides. So really, when we look at this here, a parallelogram, quadrilateral, because inside both of those, we do have the categories of rhombus and rectangle. And really right in the middle of rhombus and rectangle is our square. We're kind of looking at this here where square kind of goes in the union of these two here because they're kind of, it's the middle of those. Does that kind of make sense? Now these here, as we continue on with the notes, you can fill this in if you want or not, the rhombus corollary. The quadrilateral is a rhombus if and only if it has 4 congruent sides, because if it has 4 congruent sides, then we can say it is a rhombus, because that's the definition of rhombus. Rectangle corollary. A quadrilateral is a rectangle if and only if it has what? 4 right angles, 4 congruent angles. Really, that's saying the same thing. 4 right angles or 4 congruent angles is saying the exact same thing. Because since it is a 4-sided figure, these angles have to add together to be 360. And if all 4 are the same, the only way they can be the same is if they are all 90 degrees. A quadrilateral is a square if and only if it is a rhombus and a rectangle. Essentially, if and only if it has 4 right angles and 4 congruent sides. It has to have both of those properties for it to be considered a square. That's also why, if probably you may or may not remember it, when we started the semester with talking about polygons, how y'all were very tempted to call a lot of the 4-sided figures rectangles. This is why we can't. Because it's only going to be considered a rectangle if it has 4 right angles. It's only going to be considered a square if all 4 sides are congruent and all 4 angles are right angles. Because if we don't know anything about the figure, its sides, or its angles, the only thing that we can call it is a quadrilateral. It has 4 sides. So, for any rhombus, so we're saying this here is a rhombus, decide whether the statement is always or sometimes true. Draw a diagram and explain your reasoning. So if we're looking at this here, they already told us it is a rhombus, yes? And by definition, a rhombus has what? Well, yes. we would have two sets of parallel sides because a rhombus is a parallelogram. By definition, a parallelogram has two sets of parallel sides. And a lot of these here, it's going to be good to, on the homework, don't draw in the book, but you can draw it out on your paper, draw the figure out, and fill the information in so we can see it. Because sometimes seeing the figure helps us be able to figure out what it's asking. Now, we also know that we have four congruent sides. So that's just from the definition of a rhombus, we can say. Now, what it's asking us is, can we say that angle Q is congruent to angle S? That's what we want to know. Always or sometimes? Always. Because why? Opposite angles in a parallelogram are congruent. Since it is a parallelogram, we can say that the opposite angles are congruent, which means Q is always going to be congruent to angle S. Any questions on this here? We ready for the next one? Okay, for any rhombus, QRST, decide whether the statement is always or sometimes true. So we look at this here, we still have a rhombus. So the same information that we had on the last figure still holds true. But this time they're asking something different. They're asking if angle Q and angle R are congruent. Unfortunately, they didn't give us nevers, but it's always or sometimes. What do we think? Sometimes, because there is a case. Only if what? Because Q and R aren't going to be opposite, but there's only one way that these two can be congruent. Yes. Are right angles. Because one of the other properties that we had for parallelograms, we had a few, because we had that the opposite sides are going to be congruent. That's just by definition of parallelogram. It also told us that the opposite angles are congruent. And it told us one last thing. It told us that the angles that are next to each other, the consecutive angles, are supplementary. They add together to be 180. So the only way that Q and R can be the exact same is if they are both right angles. They're both 90 degrees. That way they add together to be 180. But any other setup, the two angles would not be congruent. Because there's no other way for these two angles to be the exact same and still add together to be 180 degrees. So this is sometimes. And really, if they are all 90 degrees, it means we wouldn't really be calling it a rhombus. We would actually be calling it a what? A square. For any rectangle, A, B, C, D, decide whether the statement is always or sometimes true. Well, what do we know about a rectangle? Four right angles. We also know that it's a what? Quadrilateral, more specifically a parallelogram, because any of these here are going to be parallelograms. So that means we have two sets of parallel sides, different color because we're getting a little scrunched on the sides, and we also know that the opposite sides are congruent. So this is kind of just by definition of it being a parallelogram and it being a rectangle. Now what it's asking us is AB congruent to BC. Always or sometimes? Sometimes. Really, the only time that this will work is if it is a what? Square. This will only work if all four sides are congruent. Now this might sound a little odd, but really this is the one case. When it's a square is the one case that we can have when this works out. Now the reason I say it's one case is because we're talking about all four sides congruent. I wouldn't consider when all four sides are 1 inch or 1 unit, 2 units, 3 units as different cases, because if it's all set up to where all four sides are congruent, then it's a square, this works. But if the dimensions varied by any other amount in size and shape, then it wouldn't work, no matter what the units are, if we make the dimensions different. So only when all four sides are congruent, making it a square, will this be true. Any other questions on this here? Okay. Decide whether the following statement is true with our rectangle. Well, again, all four sides are congruent, and because it's a parallelogram, our opposite sides are, I just said that, and all four angles are right angles because it's a rectangle, and the opposite sides are congruent. Bless you. Let's see what it's asking. AB is congruent to CD. Always or sometimes? Always. Well, that's just kind of the definition of rectangle. Or it's kind of would be the rectangle corollary. Because we can also call this always kind of by the rectangle corollary, because that's what the rectangle corollary tells us. Or we can actually consider it by the properties of a parallelogram. Any questions on this here? Because actually it's not the rectangle corollary. It would be purely by the definition of parallelograms. Because the rectangle corollary only tells us that all four angles are right angles. It says nothing about side lengths. Okay, let's look at this one here. For any square JKLM, it is always or sometimes true that JK is perpendicular to KL. Well, by definition of a square, well, all four sides are congruent. What else do we know? Four right angles. Now, what we're wanting to say is that JK and KL are perpendicular. If two lines are perpendicular, they do what? They intersect at a right angle. Always. And this here we can say by the square. Make sure I spell this right. Corollary. Yep, already spelled it wrong. Square. O-L-L-A-R-Y. C-O-R-O-L-L-A-R-Y. Corollary. By a square corollary. Because that's just by what a square is. Because a square is going to have 4 right angles. So any place where the two sides meet will be perpendicular to each other. Questions on this here? All right. Any questions on any of this here, what we've done so far? No, because we've had a question like this already. Sketch a quadrilateral. A quadrilateral has 4 congruent sides and 4 right angles. Sketch and classify it. Well, 4 right angles. 4 congruent sides. Exactly, this would be a square. As if it has 4 right angles and 4 congruent sides, we're going to call it a square. As we've stated already, we can technically call it a quadrilateral. We can also call it a parallelogram. And it does still fit with the definition of rhombus and rectangle, but we're always going to use the most specific definition of it. And the most specific one for this here is a square. The only reason we would use the others is if it asks us to list all classifications of the figure. Questions on this here? Classify this special quadrilateral. Since it's not asking for all of them, we're only going to look at the most specific definition. Now, because it does have 4 congruent sides, well, because it has 4 sides, we know that it is a quadrilateral. Now, since it does tell us that 4 sides are congruent, we can say that it is definitely a rhombus, which also makes it a parallelogram. But because this angle here is 70 degrees, we know it cannot be a rectangle or a square. Because this angle would have to be what? 90 degrees. If it's not 90 degrees, we know it can't be a rectangle, and therefore it can't be a square. So our most specific definition for this here is a rhombus. All right, let's classify this here. Well, we know the most general term that we can call this figure is a what? Quadrilateral, because it has 4 sides. Any 4-sided figure is a quadrilateral. But we also have what? 2 sets of, which makes it a parallelogram. Now, it also told us that these 2 sides are congruent, yes? But since it's a parallelogram, what else do we know about the sides? The opposite sides are congruent, yes? So since this has 1 mark, this will also have 1. Since this one has 1, this one will also have. So it not only tells us that it is a quadrilateral and a parallelogram, but we can also find out by the definition of parallelogram, all 4 sides are. Do we know anything about the angles? No. So we can call it a rhombus. Could it be a square? Most likely no. But if all 4 angles were right angles, then it could be a did it tell us anything about the angles? Well, no. So could it be a square? I mean, yes, but most likely it's not. Because unless they tell us what the angles are, we cannot assume it to be true. So the most we can call this is a rhombus. Because as soon as they tell us one of the angles is 90 degrees, or we find a way to find out that one of them is 90 degrees, then we could say that they're all congruent. But until then, we can only call this a rhombus. Okay. Now for the last few here, what we're going to do is state all the names for each figure, all the possible names. Now if we look at number 1, yep. So it would be a quadrilateral, and exactly it would be a parallelogram. And we know it's a parallelogram because it is a square and a rectangle, and it would be a rhombus. Because if it is a square, we know for certain it has to be a rectangle and a rhombus. So this one here actually gets all of them. How about number 2? Yes. Because we can see that it does have 4 sides. Now we're not told about the length of any sides or the angles or if any of the sides are parallel. So the only thing we can say for certain is that it's quadrilateral. If it does not fit any of the other categories, this is all we can name it. Questions on this here? Let's look at the next 2. Number 4. Well, quadrilateral, exactly, we can call it a rectangle, and we can call it a parallelogram. Anything else? Square would have, it has had 4 right angles, yes? What else does a square have? Are all 4 sides congruent? No. So we can't call it a square because we have 2 sets of congruent sides. Rhombus, again, would be 4 congruent sides. Because a rhombus is going to be 4 congruent sides. So we can't call it a rhombus or square because all 4 sides are not congruent. That's it. Any questions on this here? Let's look at number 5. Yes. It would be a quadrilateral, tripped over my own tongue, and a parallelogram. Because it's quadrilateral because it has 4 sides. It's a parallelogram because we have 2 sets of parallel lines. So rhombus would need what? Do we have anything about the sides? So we can't call it a rhombus. Can we call it a rectangle? Do we have any of the angles? Because a rectangle would be 4 right angles, so we don't know anything about the angles or the side lengths besides the fact that the opposite sides are congruent and the opposite angles are congruent. And the consecutive angles add up to be 180. We don't know what any of them are. If we were able to find out or it gave us one of the angles, well, we could find the rest from there. But until then, all we can really classify this is a quadrilateral with a parallelogram, because that's all the information it gave us. All right. Well, number 5 showed up again, so we'll not worry about it, because we just did this one. Let's look at number 8. We can go quadrilateral first. And we could say a rectangle because of the 4 right angles. Parallelogram. Almost. Because square has 4 right angles and 4 congruent sides. So because it doesn't have 4 congruent sides, we can't call it a square. So it would just be these 3 here. Any other questions on this here? These are the last 2 we're going to look at. Number 10. Quadrilateral. Is it a parallelogram? For it to be a parallelogram, we need 2 sets of parallel lines. Now, if it doesn't tell us that, we also know if the opposite angles are congruent, then it is a parallelogram. The other way is if the opposite sides are congruent, then it's a parallelogram. It's just going to be a quadrilateral. Because if it's not a parallelogram, well, rhombus, rectangle, and square are all parallelograms. So if it's not a parallelogram, it can't be any of those 3 there. So the next one, let's start out with quadrilateral. It would be a parallelogram. It would be a rhombus. Because rhombus is all 4 congruent sides. All 4 sides are congruent. And for it to be a rectangle, we need 4 right angles. Are all 4 angles 90 degrees? Well, it's not a rectangle, which means it cannot be a square. And that is it. I believe so. So your homework is a worksheet.